Hello, I'm Patricio Dieck, and this is my Moustrap project. So first off, I'm going to start off by explaining the design characteristics and how it affects its performance and the way it relates to physics. So first of all, I decided not to put on wheels in the front because these are big enough and they will do all the work. That reduces the amount of friction that we have to deal with in the whole system. And these wheels, we only did two, like I explained, and the traction here is hot glue, and that gives us a better grip onto the ground, and that can help us if the moustrap goes really fast. We have a way to exert all that energy into the ground, and therefore making us accelerate. And then at the axle right here, I decided to do a very small design with the axle, so there is not as much friction or energy wasted in the wheels turning. So that's the design of the wheels. That's the design of this. These nails were added to the front for extra weight since there's no more wheels down here. It will give us a better performance and more stability while we're accelerating, especially since this coil is really tightly wound. And then the lever arm was a pencil and gives us a lot more. We pull it back and it grabs right here. And the reason why I did that is for there to be a lot more string to coil around the axle and give us a lot more material to wrap around and give us a lot more potential energy in the form of elastic potential energy. And that's, once we coil this around, it will unwind itself, and that'll project the car forward. And the way we store the energy is in the coil when we wind this up, and that energy is transferred into the axle, into the wheels, and exerted into the floor to go forward.